Good morning, or day, or evening, el clase. That's Spanish for the class. Today we're going to finish the notes on circles, and that's it. Just a little bit left from this section or this chapter on circles, the section on circles. But it's a more technical section. It's a little bit more involved. And that's because it's a bit of algebra. Essentially, we're going to look at the equation that generates a circle on the coordinate plane if you would graph it. Now, you won't actually be doing any physical graphing yourselves, like drawing graphs, because this is the SATs. You don't have to do that, so you won't have to do that for any of my practice either, or the practice. But you will need to, the problems will be giving you graphs and asking you what the equation of the circle is, or interpreting the equation in other ways. So here we go. The equation of a circle is this mess right here. Do you see this mess that I highlighted? X minus h quantity squared plus y minus k quantity squared equals r squared. Now, what does all these variables mean? Because when you're actually given a real equation, you won't have you'll have numbers in for all but two of these variables. Okay. Well, the x and the y are letters that won't be filled in because that's actually the variables. So like when you have an equation of a line, you have y equals 2x plus 4, right? X and y aren't filled in. And speaking of a line, the general formula for a line is y equals mx plus b. That might sound familiar, right? So the general form has a bunch of letters, but we fill in for m and b when we're given a specific line. Well, in this case, there will be numbers filled in for h, k, and r. And what those numbers actually mean, what these h, k, and r will actually represent something about the circle. R represents the radius of the circle. Okay, so whatever number's in for r will be the length of the radius. H and k, now notice there's a minus here, but h and k are, without the minus, the positive h and k will be the ordered pair of the center of the circle. You can see this going on in this image right here, HK. So if HK is, let's say, 2, 3, so the center is at 2, 3, you'd put x minus 2, well, positive 2 still has a minus here, and then x and y minus 3. This is what that would look like. And then if it has a radius of 2, then it would be a 2 here. And that would be the equation of the circle, and that's just one I'm making up off the top of my head. That'd be the equation of the circle with radius 2 with center at 2, 3, the ordered pair. So hopefully this is making sense. It's the equation of the graph of a circle. Okay, so what does an example look like? Is that your question? I'm sure that's your question right now. Oh, first of all, sorry. If the center of the circle is at the origin, ordered pair 0, 0, then 0 will be filled in for h, 0 will be filled in for k. X minus 0 is x, y minus 0 is y. So the equation of a circle at the origin would be x squared plus y squared equals r squared, where r is the length of the radius. So if the radius is 10, x squared plus y squared equals 100 would be the equation for the circle at the origin, whose center is at the origin and has radius 10. All right, so which equation could represent the circle shown in the graph below that passes through the point 0, 1? So the circle itself passes through the point 0, 1. Okay, that is this point right here. X is 0, y is negative 1. Sorry, negative 1. Okay, on the ordered pair. Remember, just a quick recap of graphing. The x-axis is horizontal, the y-axis is vertical, and the ordered pair is always x first and then y. So 0 means you stay at the origin, and then negative 1 means you go down 1. Okay, so we have this point here. So which of these could represent this circle? Okay, that's the question. excuse me. So if one way to test this out, so what it means for the circle, this equation to be the circle's equation is that every point on the line can be filled in, every point on the circle, I'm sorry, can be filled in into this equation. So if I picked any of these points on the circle, not all of them are obvious what they are, but any point that would be, any point actually, even if it's not obvious, if I knew what it was, which I couldn't tell you because it's not obvious, but I plugged it in on this side for the ordered pair that you'd get on that circle, like this point right here. You plug in for x, you plug in the value for y, you evaluate, and you get 16 out. Okay, that's what all these points will do. Every single one of these, you plug in for x, you plug in for y, you evaluate, and you'd get this out if this was the equation for this circle. So one way you can test this out is you could actually take the ordered pair 0, 1, negative 1, because they gave that to us. We know that for sure. All these other ones we couldn't assume, but we know that this is a point on the circle, 0, negative 1. And I could plug that in for the x and y value. If I get 16 out on the other side, then that is the equation for this circle. If I get anything but 16, then it's not. Okay, so if I plug in 0, I'm going to get 0 minus 3, and I plug in negative 1, I'll have negative 1 plus 4. Okay, that's what the equation they gave us. I'm looking at A. I'm just looking at this first one. So I get negative 3 squared. Now be careful with a negative 3 squared. That means negative 3 times negative 3, which is a positive 9. Negative 1 plus 4 is positive 3. Okay, that's positive 9. 9 plus 9 is not 16, that's 18. Okay, so I'm just going to do this for each of these. And if I plug in negative 0, negative 1 in for the second line, and I will get something much bigger than 18. So that's not right. And you'll see, if you look through this, I plug in 0 for C, you'll see that C, letter C is not correct, and D is correct. So D is the correct value. But just by plugging in this point into here. Now, there's possible that you could maybe use process of elimination so you wouldn't have to try every single one of those because, you know, on the SATs you're timed and you want to be fast. If you look at this point, it looks like this point right here. And we can, so it looks like that is 1, 2, 3 in the x positive direction because x is positive to the right, negative to the left. But then it's down. Y is negative, down, positive, up. So 1, 2, 3, 4. So it looks like it's 3, negative 4. The point is 3, negative 4. If it's a positive 3 and a negative 4, we could actually save some time by eliminating B and C. Now, all of these say 3 and 4 here, okay? But not all of them have the right sign. Because remember, it's x minus the ordered pair and y minus the ordered pair. Well, if the ordered pair is negative 4, then it would be y minus negative 4. And they're simplifying the y minus to plus. Okay? Y minus negative to plus. So the ordered pair, the center of the circle is at 3, negative 4. So these two, B and C, actually have the wrong center. This ordered pair center would be negative 3, positive 4. So that would actually be over this way and then up this way somewhere up here. Well, actually, it would be 1, 2, 3, 1, 2, 3, 4. It would be a circle with a center up here. So hopefully that makes sense. So you could actually have eliminated B and C and then only had to test A and D. You couldn't, if 16, so another thing is for A, if 16 was the answer, then the radius would be 4, because r squared, right? R squared is what this is. Well, this is r already squared, so the square root of this would tell you what r was, and that'd be 4 squared is what's 16. So 1, 2, 3, 4. You can see it's a little above 4. It's not quite 4. Going this way, 1, 2, 3, 4. You can see it goes a little bit above, and that's what's happening. It's actually the square root of 18, and the square root of 18 is not a nice number. I mean, not an integer. Square root of 18 is a little bit more than 4. Okay, and you can kind of see the radius here goes a little beyond 4, which would be right there. It goes a little beyond. Just realized I'm not zoomed in as far as I usually do. So hopefully you can see everything so far. And it makes it a little bit easier to see that 4 would be the ordered pair right there. 1, 2, 3, 4. It goes a little beyond that. So maybe you could even figure it out without doing all this work and save a lot of time. But I just wanted to go through the process. So point P lies in the interior of a circle in the xy plane with equation, and here's the equation of the circle, x plus 4 squared plus y minus 7 squared equals 100. Which of the following could be the coordinates for point P? So if you think about a circle in the ordered pair, or in the coordinate plane, it's going to have a whole bunch of points inside it. Now this isn't the same image, right? But all these points are inside the circle. It's asking, the question is, which one of these points is inside the circle? Which one of these points can be inside the circle? So the ordered pair that the center of the circle would be, remember it's minus a negative 4 because x minus h, y minus k. So the ordered pair would be negative 4, positive 7. The radius, r squared, would be 10 squared, which makes 100, so the radius would be 10. Okay. So when you plug a point in, so if I plug one of these points in, the question is it, if I take this, evaluate this, is it greater than this side? So if plugging a point in that's not, sorry, let me just pause for a second. Okay, gather my thoughts again. If I'm plugging a point into the into the equation of a circle, and it's true, I get 100. So I'm plugging the values in and I get 100. That means that point is on the circle. If I get a value less than 100 out of plugging a point in here, that means that it's inside the circle. And if I plug a point in to the x and y here and evaluate and get a number greater than 100, that means it's outside the circle. Hopefully that made sense. Okay, so we're going to plug in these points in here for x and y and evaluate, and if it's greater than 100, then it's outside the circle. If it's exactly 100, then it's not technically in the circle because it's on the circle. If it's less than 100, that's what they're asking for. Okay, so I'm plugging in A, and it's exactly on the circle. Okay, I plugged A in, and I evaluated, and I got 100. So that means it's not inside the circle, it's on the circle. So that's not what they're looking for. Okay, I plugged in B, negative 3, negative 3. I know I just glossed over. These are very similar problems. Each of these, just the numbers that you get are different. So when I plug in negative 3 plus 4, that's a positive 1. 1 squared is 1. Okay, negative 3 plus minus 7. I get negative 10. Remember, a negative squared becomes a positive. And I get 101, which is a little bit bigger than 100. So that means it's outside the circle. Okay. C is our answer because we plug it in and we plug in negative 8 and negative 2 and we get something less than 100. So C is actually our answer, but just to show you that D isn't the answer, I did D because it's on the circle also. That means it's not inside the circle. So C is our actual answer. Okay. So that's how you can find out whether a point is on the circle, in a circle, or outside a circle. Remember, inside a circle is less than the radius squared, on a circle is exactly equal to, and outside a circle would be greater than the radius squared. Okay. All right, so here's probably one of the more common problems in the problem set, if I remember correctly, is giving you this mess, and they're saying, what is the center and the radius of the circle who has an equation this, okay? So we're going to have to get used to doing this. What we need to do is get this equation into the form x minus h squared plus y minus k squared equals r squared, okay? First thing I'm going to do is I'm going to notice that everything here is divisible by 3. So 3 can be divided by 3, 3 can be divided by 3, 12 can be divided by 3, 18 can be divided by 3, 69 can be divided by 3. So I'm going to do that. So that just makes it easier to deal with. This is the equation. I can divide both sides by 3 and divide every term by 3. All right, then I want to group up the x and the y's together. So I have x squared minus x. I'm just rearranging here. X squared minus x plus y squared plus 6y. And the 23 on this side just hangs out there. Now here's the trickiest part of this, okay? What's going on here is I want to be able to take x squared minus 4x and I want to convert that to x minus something quantity squared, okay? And I'm going to add 4 to both sides. I'm just going to show this whole thing here and then walk through this. I'm adding 4 to this because when you FOIL x minus 2 quantity squared, you would do x minus 2 times x minus 2. Okay? X minus 2 times x minus 2 would be, let me actually type this, maybe I should type this up for you guys. So you got to make sure I go above my little picture. So if I have x minus, let me do the equation thing, x minus 2 times x minus 2, okay? And I need to FOIL this. So I have x times x is first, okay? Outer is x times negative 2 or negative 2x. Inner is negative 2 times x or negative 2x. And then last would be negative 2 times negative 2 times negative 2, which would be a positive 4. Okay? So the next line of this would be, let me just line up these equal signs a little bit here. And I'm going to be equal, and it'll be x squared, okay, minus 4x plus 4. Okay? So now the question is, how do I go from having this right here is what I had, right? I had this part, oops, trying to highlight that. Well, red is so angry. So this is what I was given, okay? And what the question is, how do I get the plus 4? How did I figure out to add plus 4 to both sides over here? Like what I did right here, okay? How did I figure that out? Because I was given the x squared minus x. Well, you can figure this out by doing the following. To go from this here to this here, which lets us go to what we really want, which is x squared minus 2 quantity squared, or sorry, x minus 2 quantity squared, is you can take the number. This will work when x doesn't have a leading coefficient. Okay, so you can take this number right here. You could take half of that. So let me just do it this way. So if I have, and I got to make sure I stay above my little screen on my window. So x squared minus 4x. I'm going to add half of that. So 4 divided by 2. Okay. I'm going to add half of that, and I'm going to take whatever I get, and I'm going to square it. And this is called the difference of squares, but that doesn't matter. So this right here is taking this number right here, whatever number this ends up being. Okay, I'm going to make this, let's make this green. And I'm going to always take half of that and square it. And in this case, that is, I keep hitting 5 instead of 6. It's going to be plus 2, taking half of that, and because half of 4 is 2. And then that's going to be 4. So that's how I got that. Pretty tricky stuff. Okay. So that's how I got 4. Okay, hopefully that made sense of how I got 4. So where were we here? Right here, how I added 4. Now, I can't just add 4 in here. I added this 4 in here, but I can't just add 4 in here and think that everything's fine and dandy. I have to add it on both sides, so I keep everything balanced. Okay. So hopefully that made sense. So, continuing on with that, so over here you can see I added a 9. Actually, let me make that a different color. How did I decide to add 9? And I had to add it to both sides for the y. So that was just for the x's. Everything I just did was just to define, to work with the x values. To do it with the y values, you would take, this is the number we're looking at. It's 6 now instead of 4. So you take half of 6, that's 3, and you square it and you get 9. And you have to add it to both sides. And the whole reason we did that is because once we add those numbers, we now have two groupings, x squared minus 4x plus 4. That grouping can be rewritten as x minus 2. So whatever that number was that you took half and then squared Well, that half is what you're going to put here. And if you wondered how this goes to that, then let's just look over here. Again, x, because this is the same as x minus 2 squared. X minus 2 times x minus 2. Okay? So whatever you use when you go to find what this is, when you have it, before you square it, that's what you're going to use here. So here, 3 is what we get when we have 6. Okay? 3 squared is 9. We're going to put in here that half before you square it, y plus 3. So hopefully that makes sense. Now over on this side, we have to add the 4 and the 9 to this and get 36. And then this is how you rearrange this equation in order to get an equation that's of the form x minus h plus x minus k. Now when you have a plus here, remember that's a minus and negative. So my center will be positive 2, and because this is a plus, negative 3. You can see that, what's going on there. Okay, my radius, then the one last thing you want to do is, well, what is r if r squared is 36? Well, 6 squared is 36. So the radius is r. So the answer to this question, what is the center and the radius, is 2, negative 3, and 6. So I might recommend you watch, maybe rewind and watch this through again to see how I did that. It does come up quite a bit. I'm going to assign after this video for the week is going to be the rest of the work packet 1, which is a multiple choice packet that we've been working on, and it has a handful of questions left, and then the free response questions. We haven't done any free response yet for the circles. Not all of them will be the circle equations. Some of them will be some of the other stuff we covered. Tangents and what is some of the other stuff we covered in this 3-part section, area, perimeter, stuff like that. So, but it'll be for the free response section as well. So hopefully this made sense. Again, feel free to rewatch it and of course ask any questions if you would like to. If you have any, feel free to reach out. Thank you and good day.